question 7. Can you do a problem similar or like identical to it, just not the same numbers, so they could see how you would do it
Similar to, but legally distinct from?
legally distinct? You need a picture of it, I have it right here.
The stuff I'm erasing right now is stuff that we'll get to in a month. Are you done? Give me something. All right, you said you had it right there?
Zoom in.
Oh, number 7.
Yes.
I'm not sure really how to do one similar to, but distinct from. I got a better idea. How about you do it and call it a quiz? Oh, I know what I can do. Oh, somebody's bound to have had it in here. They are so much different. Let's see. There is friction somewhere. Well, there's got to be friction here. And there does not have to be any friction there. And we'll call this B, C, and D. These are ideal roots. And this is horizontal. Is that seem close enough?
Yes.
Mass of A, mass of B, mass of C, mass of D. 8, 6, 4, 2. I might change one of these numbers as we go, and it seems like we'll need a coefficient in here somewhere.
Yep.
So the coefficient of static friction in this intersection is, again, I might change one of these numbers. This has convenience of only one thing that is not horizontal or vertical. All right, what's the first step?
Force diagram.
There are several people who nodded to back you up there. All right, so I got A,
matters, but I think in the original problem, the rope on that side is connected to the top one, and the rope on that side is connected to the bottom.
Yeah, that is correct. I was doing something that was slightly different. The process is the same. The answers probably are different. All right, and I believe B is just barely not moving.
Yes.
So it's like breeze comes along, B will start to slide. It's, I guess a breeze hits it on the left-hand side, so coming from the left, B will start to move. All right,
You said, and that's because you did it in the flipped order?
yep.
Okay.
Well, I mean, sorry, that is what I've done differently. The barely not moving, I think, was part of the original.
Yeah.
All right, force diagram. We got F-Tom.
So on A, we have tension going up and weight going down.
Are you good with this? Okay.
On D, you just have weight going down and then tension going up.
On B,
Let's hold on just a second. Let's go ahead and correct a mistake.
Subscript D.
Subscripts. D, A. Do I need a subscript on the tensions for ideal ropes?
No. Yes,
Why?
because we're gonna have a point where they intersect and they think it's gonna matter.
Just on general principle, just what you're doing. All right, first off, we do need subscripts on the tensions. Perhaps a more succinct explanation about why we have more than one rope. For an ideal rope, the tensions only is the same throughout that one rope. It doesn't have Jedi powers to force the other ropes to obey the same. All right, Carolyn, I cut you off. You were saying?
on B, wait, sub B, and then friction to the left, and sub B, yes.
Sure.
Yeah, well, do we even need it if it's only in one place? Because then you only have one pair.
Yeah, no, we don't, that's not necessary. Let's go ahead and mark this as frictionless. And frictionless here too.
And then there's tension going to the right, and that would be, so. And then normal force going up.
Okay.
C has weight going down, or weight subscript C. And then normal force up. And, yeah. And then tension going to the left.
So, I have a question with normal force.
Yes.
So because C is on the bottom of B, you also have the normal force of B going down?
Absolutely. There's one more force missing from C.
Friction to the right.
Yes. They come in pairs, so the white B's are a pair, and then there's gonna be a friction pair here. Otherwise, if that were not there, C is gonna accelerate to the left. And the whole thing was in equilibrium, which It's stated in the problem, but it did not state here. All right. One more thing to do a force diagram on.
The wall with the rope.
We don't have to do the wall, but we can.
Then we will not. We do not have.
The table. Or,
We don't have to do the table. I mean, if we were doing the full, complete force diagram, then yes, the table would be involved. However, the one thing that you also need to do is that connection point. These are 3 different ropes connected at this spot right here, so we have to do that one also.
Oh,
Because forces come in pairs, where's the other part of this one? Or that one? And then there's that one connecting the wall. So FD, we'll put W for wall. FDD. And FDB. And I believe you're trying to find that angle?
Yeah.
Or that force, one of the,
Both, I think.
yeah.
the force factor. All right. We have gotten that far. What's next?
it would,
What comes after a force diagram? Let's just hit the process.
Access.
All right, acceleration, 0. Coordinate axes,
I think. Up, and to the right.
okay, for everything?
Oh, yeah.
Okay. Decomposition?
We only have to decompose the FTW.
All right, so if we decompose that, we still have with FTD going down, FTB going to the left, and then what's the horizontal component of FTW?
goes. FTW cosine.
Like you mean it.
Yeah, FTW cosine theta.
And this hopefully is the other one. All right, we've decomposed.
Now you have to figure out the equation.
Okay. How many equations will we have?
A whole lot. So,
We can narrow that down.
really?
I don't think we need one for A. Or do we?
We will.
We will. Well, a lot of them, Should-
Oh, sorry. I thought you were saying A at first. You said 8?
Yeah.
a lot of them should be 0, right? Because they're not moving, or they're in equilibrium.
Everything's in equilibrium, so all the equations will be equal to 0, which is convenient. For a complex problem like this, it makes it a whole lot simpler.
I think it's going to be 10.
How'd you get 10?
So I was thinking it's gonna be 2 equations per object. So A, B, C, D, that's 8. And then the 3 tensions, that's, I'm gonna consider that an object in and of itself. So I'm gonna think there's two equations there.
All right, Carolyn, now's your chance to go, Ibrahim, what were you thinking?
Wow, now.
He's right, except for A and D only need one each because they only have one, they're only on one axis. There's nothing on the X or the I hat axis.
Oh,
Yeah, it is indeed 8. If you did want to do a horizontal one here, it would be something clever like 0 equals 0.
well,
which presumably you were gonna do,
Most different.
or you were wrong, which just doesn't seem right.
Just, no.
All right, so we got our AJ equation.
F T subscript A minus weight equal mass.
Okay.
Yeah, oh, mass of A, but A zero.
Yeah.
Zero.
So times 0.
So can we rewrite this, so, like, would you be against, like, just writing that down initially just as FTA minus W, or like equals WA?
I'm fine with that.
You're fine with
Just,
this?
if you wanna do multiple steps in your head, I'm okay with that, just don't make, careless error. All right, so we got the BI. And then B. And then I'll just call it R. All right, 7 to go.
Okay.
You got,
I was gonna do BI would be, I guess, FT.
FTP.
Yeah, FTB.
Okay.
Is equal to F.
Let's not forget subscripts. All right, so just jumping ahead, technically that minus that equals 0. Or one step further, that minus that equals math times 0, and which ultimately gives you this. Okay.
YB equals WB?
All right, we've had 3 people, 3 equations.
Are we setting all of these equal to the other side because there's no acceleration?
Yes. If acceleration is 0, forces up equal to forces down, forces left equal to forces right.
For CI, it would be.
Oh, wait, before you do it, I want to give someone else a chance to chime in. New voice, new equation.
FB equals FTA.
Okay.
CJ, Y, oh, yeah, YC minus WC
You said YC,
minus wait, C
okay.
equals 0.
Look at the vertical forces that are acting on C. There are 3 forces.
Equals FB, or,
Vertical.
oh, vertical, sorry. YB,
Yeah, where does YB go?
equal to FB.
Sure. I'm sort of mixing
Wouldn't it be?
techniques there. I'm gonna do, since you started out with that, minus YB equals 0, then if you added YB, what you said is actually right, but, we'll just put it right there for now. All right, so we have 4 people, 3 equations.
Wait, hold on. That's 5 equations.
3 to go.
Oh,
Read my mind, fill in the blanks with the right words.
good.
You revealed that your dad was a physics major. You should know how
No, it's-
we all think.
Yeah.
Joey, you about to do one?
FTD,
You're doing, which one?
force of tension D. I'm doing D, J. Force of tension D equal to weight B.
All right. Two equations, 3 people. Is it time to avoid eye contact? GT, it looks like you're about to go.
Yeah, okay, so for the R I hat, would it be FTW cosine theta equals FTB?
All right. And last one. Well, I've heard Justin's voice today already, so Micah. Nailed that last one.
FTW sine theta equals FTD.
All right. And that's a D, not a P. All right. What's next?
Substitution.
All right. We'll substitute here. I know for what do we have an independent equation?
Weight equals.
And
Acceleration.
not acceleration.
Friction.
Yeah, friction. All right. We know that W equals, yep, and friction equals,
Mu
S
sub
times
S.
L.
yes. All right, so in this first one here, I know that FTA is gonna be equal to MAG. And let's just, did I set, let G be 10 in that problem? Meters per second squared? I did not. Okay. Well, we're on Earth 2 here, so we're gonna make it 10. And whether you want to plug in numbers now or later, you know, we're here. So that's 80 newtons. For this one, we have FTV is equal to mu